In this video, we will discuss reduction formulae which are derived from beta function and which are highly useful in solving problems on double and triple integrals, about which we shall see in my later videos. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. In my previous videos, we have learned many things about beta function. We have beta function as bm comma n equals integral from 0 to 1 x raised to m minus 1 1 minus x raised to n minus 1 dx, where m and n are positive rationals. To get the reduction formulae from this beta function, we will substitute this x equals sine square theta, so that dx becomes 2 sine theta cos theta d theta. Change in limits due to this substitution will be, when x is lower limit 0, theta will be also 0 because sine 0 is 0. When x is this higher limit 1, theta will be pi by 2 because sine pi by 2 is 1. Now the beta function reduces to integral from 0 to pi by 2 of sine 2m minus 2 theta 1 minus sine square theta raised to n minus 1, and for this dx 2 sine theta cos theta d theta. This will be integral from 0 to pi by 2 of sine raised to 2m minus 2 theta. For 1 minus sine square theta, we write cos square theta, so that it will be cos raised to 2n minus 2 theta into 2 sine theta cos theta d theta, which will be this 2 integral from 0 to pi by 2 of sine raised to 2m minus 2 theta plus this sine theta will be sine raised to 2m minus 1 theta, and cos raised to 2n minus 2 theta plus 1 for this cos theta will be cos raised to 2n minus 1 theta d theta. If we replace this 2m minus 1 by p and this 2n minus 1 by q, bm comma n will be 2 integral from 0 to pi by 2 of sine raised to p theta into cos raised to q theta d theta, and the first reduction formula that we get is integral from 0 to pi by 2 sine raised to p theta into cos raised to q theta d theta is half b m comma n, where m is p plus 1 by 2 and n is q plus 1 by 2. So we write the first reduction formula, integral from 0 to pi by 2 sine raised to p theta cos raised to q theta d theta equals half b p plus 1 by 2 comma q plus 1 by 2. This reduction formula helps us to prove a very important result which we have been using in my last videos on special functions, gamma function and beta function, which is gamma half is square root of pi. For proving this result, we will put p equals q equals 0. That gives us integral from 0 to pi by 2 of 1 d theta, which is half b half comma half, which is half into gamma half upon gamma half plus half. Here integration of 1 d theta is theta from 0 to pi by 2. This will be half into gamma half square upon gamma 1, which is 1. So this will be pi by 2 minus 0 equals gamma half whole square upon 2. This 2 cancels from both sides. Taking square roots from both sides, we get gamma half equals square root of pi. From the basic reduction formula, we will get its different versions which are useful in solving problems. For the first version, we will put p equals n and q equals 0, that will give sin raised to n theta d theta equals half gamma n plus 1 by 2 into gamma half upon gamma n plus 2 upon 2. In case 1, when n is even positive integer, we get half into gamma n plus 1 by 2 will be n plus 1 upon 2 minus 1 factorial into gamma half upon gamma n plus 2 upon 2 will be n plus 2 upon 2 minus 1 factorial, which will be n plus 1 upon 2 minus 1 into n plus 1 upon 2 minus 2, so on and so forth. When n is even positive integer, this will end in 3 upon 2 into half into gamma half into this gamma half upon n plus 2 upon 2 minus 1 factorial will be n plus 2 upon 2 minus 1 n plus 2 upon 2 minus 2, so on and so forth. For even positive integer will end in 4 upon 2 into 2 upon 2. This further will be n plus 1 upon 2 minus 2 will be n minus 1 upon 2 into n plus 1 minus 4 upon 2 will be n minus 3 upon 2, so on and so forth. 3 upon 2 half into gamma half whole square upon n plus 2 minus 2 will be n upon 2 into n plus 2 minus 4 will be n minus 2 upon 2 into so on and so forth, 4 upon 2 into 2 upon 2. Now let us write this result properly. We will start with n minus 1 upon 2 upon n minus 2. This 2 cancels with this 2, so it will be n minus 1 upon n. Next, we consider n minus 3 upon 2 upon n minus 2 upon 2. This 2 cancels with this 2 and we get n minus 3 upon n minus 2. If we consider for the third factor, we write n minus 5 upon n minus 4 into. Next we consider this 3 upon 2 upon this 4 upon 2. Cancelling this 2, we get into 3 upon 4 into considering this half upon this 2 upon 2 and cancelling this 2, we get 1 half, and finally gamma half whole square will be square of square root of pi, that will be pi, multiplied by this half will be pi by 2. So this is the second reduction formula that we got. Integral from 0 to pi by 2 of sin raised to n theta d theta equals n minus 1 upon n into n minus 3 upon n minus 2 into n minus 5 upon n minus 4, 3 upon 4, 1 half and pi by 2, provided n is an even positive integer. Now we have the reduction formula. Let us see how to use this to solve integrals. Integral from 0 to pi by 2 of sin raised to 4 theta d theta. Here n, which is 4, is an even positive integer. By applying the reduction formula, we write 4 minus 1 upon 4 into 4 minus 3 upon 4 minus 2 into pi by 2. That will be 3 upon 4 into 1 upon 2 into pi by 2, which will be 3 pi by 16. Second example is integral from 0 to pi by 2 of sin raised to 6 theta d theta, which according to above reduction formula will be 6 minus 1 upon 6 into 6 minus 3 upon 6 minus 2 into 6 minus 5 upon 6 minus 4 into pi by 2 will be 5 upon 6 into 3 upon 4 into half into pi by 2 equals 3 ones are 3 twos are, which will be 5 pi by 32. In fact, these integrals can be solved by regular definite integral techniques, but the reduction formula provides a ready-made solution to this. We have seen in the first case when n is an even positive integer. We have now in the second case b, when n is an odd positive integer, the integral becomes half into so and so forth, 4 upon 2 into 2 upon 2 into gamma half upon into so and so forth, 5 upon 2 into 3 upon 2 into 1 upon 2 into gamma half. This will be starting from these two initial factors. After cancelling these two, it will be n minus 1 upon n into considering these two factors. After cancelling these two, n minus 3 upon n minus 2 into considering these two factors and cancelling these two, it will be n minus 5 upon n minus 4 into considering these two factors and cancelling these two, it will be 4 upon 5 into cancelling this 2 with this 2, it will be 2 upon 3. This half cancels with this half. This gamma half cancels with this gamma half, giving 1 here. So the third reduction formula, integral from 0 to pi by 2 sin raised to n theta d theta, when this n is an odd positive integer, is n minus 1 upon n into n minus 3 upon n minus 2 into n minus 5 upon n minus 4 into 4 upon 5 into 2 upon 3 into 1. Reduction formula when n is an odd positive integer. For example, integral from 0 to pi by 2 of sin raised to 5 theta d theta, where this theta is an odd positive integer, will be 5 minus 1 upon 5 into 5 minus 3 upon 5 minus 2 into 1 will be 4 upon 5 into 2 upon 3 into 1 will be 8 upon 15. Integral from 0 to pi by 2 of sin cube theta d theta will be 3 minus 1 upon 3 into 1, that is 2 upon 3. Integral from 0 to pi by 2 of sin raised to 7 theta d theta will be 7 minus 1 upon 7 into 7 minus 3 upon 7 minus 2 into 7 minus 5 upon 7 minus 4 into 1 will be 6 upon 7 into 4 upon 5 into 2 upon 3 into 1 will be 3 ones are 3 twos are 16 upon 35. You will find that solving definite integrals of higher powers of sin theta is so easy by using this reduction formula. In the first reduction formula, in the second case B, we will put P equals 0 and Q equals n. So the integral becomes cos raised to n theta d theta equals half into gamma n plus 1 upon 2 into gamma half upon gamma n plus 2 upon 2. In the first case, when n is even positive integer, integration from 0 to pi by 2 cos raised to n theta d theta will be similar to sin raised to n theta d theta, that is half into n minus 1 upon n into n minus 3 upon n minus 2 into n minus 5 upon n minus 4 into 3 upon 4 into half into pi by 2. And in the second case, when n is odd positive integer, integral from 0 to pi by 2 cos raised to n theta d theta will be same as sin raised to n theta d theta, half into n minus 1 upon n into n minus 3 upon n minus 2 into n minus 5 upon n minus 4 into 4 upon 5 into 2 upon 3 into 1. So we understand that in case 1, when n is an even positive integer, when we have integral from 0 to pi by 2 sin raised to n theta d theta equals integral from 0 to pi by 2 of cos raised to n theta d theta equals n minus 1 upon n into n minus 3 upon n minus 2 into n minus 5 upon n minus 4 into 3 upon 4 into half into pi by 2. And in case 2, if n is an odd positive integer, then we have integral from 0 to pi by 2, here it should be 0 to pi by 2, of sin raised to n theta d theta equals integral from 0 to pi by 2 of cos raised to n theta d theta is n minus 1 upon n into n minus 3 upon n minus 2 into n minus 5 upon n minus 4 into 4 upon 5 into 2 upon 3 into 1. Please note that for even positive integer and odd positive integer, this part of the reduction formula remains the same, and what changes is this part only. Finally, we will put p equals m and q equals n in the reduction formula from 0 to pi by 2 of sin raised to p theta cos raised to q theta d theta equals half gamma p plus 1 upon 2 into gamma q plus 1 upon 2 upon gamma p plus q plus 2 upon 2. We will get integral from 0 to pi by 2 of sin raised to m theta into cos raised to n theta d theta equals half into gamma m plus 1 upon 2 into gamma n plus 1 upon 2 upon gamma m plus n plus 2 upon 2. In case 1, we consider both m and n to be even positive integers. So, integral from 0 to pi by 2 of sin raised to m theta into cos raised to n theta d theta will be half into m plus 1 upon 2 minus 1 factorial into n plus 1 upon 2 minus 1 factorial upon m plus n plus 2 upon 2 minus 1 factorial, which will be half into m plus 1 upon 2 minus 1 into m plus 1 upon 2 minus 2, so on and so forth, 3 upon 2 half into gamma half into n plus 1 upon 2 minus 1 factorial will be n plus 1 upon 2 minus 1 into n plus 1 upon 2 minus 2 into so on and so forth, 3 upon 2 into half into gamma half upon m plus n plus 2 upon 2 minus 1 factorial will be m plus n plus 2 upon 2 minus 1 into m plus n plus 2 upon 2 minus 2, so on and so forth, 6 upon 2 into 4 upon 2 into 2 upon 2. We will rewrite the last step. Cancelling these two from numerator and denominator, we get equals m minus 1 into m minus 3, so on and so forth, n minus 1 into n minus 3, so on and so forth, upon m plus n into m plus n minus 2, so on and so forth. And finally, this gamma half into this gamma half will be gamma half whole square, that will be square root of pi whole square, that gives pi multiplied by this half gives pi by 2. In case 2, if m and n are both odd positive integers, then we get, working in the same manner, integral from 0 to pi by 2 of sin raised to m theta into cos raised to n theta d theta equals m minus 1 into m minus 3 into so on and so forth, n minus 1 into n minus 3 into so on and so forth, upon m plus n into m plus n minus 2, so on and so forth, into 1. So what we observe here is, when m and n are even positive integers or odd positive integers, this part of the formula remains the same. What changes is, for even positive integers, we have to multiply by pi by 2, and for odd positive integer, we have to multiply by 1. For even positive integers m and n, we have, based on this, we will solve integral from 0 to pi by 2 of sin square theta into cos raised to 8 theta d theta, where m is 2 and n is 8. By using above reduction formula, it will be 2 minus 1 into 8 minus 1 into 8 minus 3 into 8 minus 5 into 8 minus 7 upon 2 plus 8 into 2 plus 8 minus 2 into 2 plus 8 minus 4 into 2 plus 8 minus 6 into 2 plus 8 minus 8 into pi by 2. So this will be 1 into 7 into 5 into 3 into 1 upon 10 multiplied by 2 minus 2 0, 8 multiplied by 6 multiplied by 4 multiplied by 2 multiplied by pi by 2, which will be 5 ones are 5 twos are, 3 ones are 3 twos are, 7 pi upon 512. In the next example, we have to evaluate integral from 0 to pi by 2 of sin raised to 5x into cos raised to 4x dx, which will be according to above formula. This 5 minus 1, that is 4, into 5 minus 3, 2. Next, this 4 minus 1, 3, into 4 minus 3, that is 1, upon m plus n, which means 5 plus 4, 9, into 9 minus 2, 7, into 9 minus 4, 5, into 9 minus 6, that is 3, and 9 minus 8, that is 1. This 3 will get cancelled, and this works out to be 8 upon 315. In the next example, we evaluate integral from 0 to pi by 2 of sin square theta plus sin cube theta d theta. Integral of this sin square theta according to the rule will be half into pi by 2 plus integral of this sin cube theta will be 2 upon 3 into 1, which will be pi by 4 plus 2 by 3, that is 3 pi plus 8 upon 12. If you like this video, please like it, share it, and subscribe to this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.